Hi guys, welcome back to the channel. Today, let's discuss this interview question. This was an interview question that was asked by Intel in one of my internship interviews that I attended. So basically, we need to plot the voltages at node A and node B for a step input. And let me first draw the input. So our input something like this would be voltage, this is time. So this is our input. Now, before we solve this problem, with interviews, it's easier to solve circuits intuitively. It kind of shows us the understanding that we have. So it's just, and it's also easier because in interviews, you cannot uh, write down a ton of formulas and solve it. So let's see how to solve this intuitively. To intuitively solve this, there are certain pointers that I tend to remember. So when it comes to capacitors, there are two things. When the frequency tends to infinity, a capacitor acts as a short circuit. And when the frequency is pretty constant, which we call it a steady state, and there is no change in frequency, a capacitor acts as an open circuit. So with these 2 points in mind, let's solve this. Uh, you can see that at this point, the frequency tends to infinity because the voltage suddenly jumps. And when t is equal to 0, the frequency tends to infinity, and the capacitor, as we discussed, would be short circuited. So let's try to draw the circuit at t is equal to 0, and the cap is short circuited. So our circuit would be something like this. So resistor here, this is the step input. Now these are resistors in parallel connection, and it's pretty easy to draw the response. So I'll try to use different colors. So this is our input, and node A, the voltage at node A will be like this at t is equal to 0. And let me and the voltage at node B will also be the same. Voltage A, this is voltage B. There you go. Now let's move on to the next part. At time tends to infinity, we call it a steady state. And you can see here, at as time tends to infinity, we see that there is no change in our input. So the frequency is equal to 0, and this is when the capacitor acts as an open circuit. So let's redraw this circuit now. If it's an open circuit, it would be something like this. Now, in this circuit, there is no path for the current to flow, so the only thing that can happen is the capacitors will start to discharge exponentially. And the rate in which the capacitors discharge depends on the time constant. But like for this question, it's just we need to know just the behavior of the circuit. So it will be something like this. At steady state, it is supposed to discharge like this, and the node B will discharge something like this. This would be node A, this would be node B. And this is how intuitively you can kind of capture the behavior of the RC circuit. I have also simulated this circuit in Spice. I will add that clip at the last to see. You can see that I put some values for R and C, and I've captured the behavior of the circuit through simulation. So first, I built the circuit in Spice. I've just sped up this part. Uh, if you guys want to see more Spice video or like actual simulations, do let me know. Here, I'm just giving a normal input step of 5 volt. To see the step input response, we need to run a transient analysis. So I'm running a transient analysis for 10 milliseconds. And the first plot is the input. Hopefully you guys can see it. And the second plot is node A. And the third plot is node B. And you can see that the simulation results is similar to our hand calculation. Thank you so much for watching and stay tuned for more videos.